All right, today we're talking about power. Chapter 3 is all about electricity and power and how we figure out the power that we need and how we figure out how to prevent problems from power like this ruining our electrical equipment. So let's get on and get started with Chapter 3 on power and power supplies. All right, let's get started with Chapter 3. This chapter is on electricity and power supplies, and we're going to hopefully by the end of this chapter understand electricity in general, and then power supplies, how to select them, and that's the overall objective. So, goal number 1, understand form factors and how it affects our power supplies. Basically, these two ideas are very closely connected, and a lot of it we've already talked about in Chapter 1. So, first thing is about form factors and computer cases. So, we know from what we've already learned in class that form factors describe the size, shape, and general makeup of any hardware component. We also know from Chapter 1 that form factors in the motherboard, the power supply, and the case have to match. We know that if the motherboard doesn't match the case, it won't screw in, and the power supply doesn't match the plugs on the motherboard, it doesn't work. So of these things, the motherboard we've talked about, which is the next chapter, kind of drives the decision-making process, but that needs to be something in our cross-check the entire time. So that's the basic definition of the form factor. And we know that making sure we have the right form factor assures that the motherboard fits in the case, all the screws line up, that the power supply gives the right voltage and the right plug-in for the motherboard. And we've at this point already taken apart whole PCs and putting them back together again. And you know you had to figure out which thing plugged in the right place. If that doesn't have the right plug, then obviously it's not going to work at all. Also, when we put in motherboards, we've seen those holes align with the case. If those holes were in a different place, they wouldn't screw in. So they have to align with those in the case. And we have to make sure all the other connections match up. And that's why in this class we've said that we're going to use ATX as our form factor so that we work with only one through the course of the class. Now, there's been a lot of form factors over time, and these are just a couple of them. But of all these form factors that you may see as you're doing shopping and looking at things online, the big thing is that you recognize which one we are using in this class and that you use the correct one, which is the ATX form factor. Now, ATX has been around since 1995. One of the reasons it's the most prevalent one is that first line right there that says it's non-proprietary. What that means is that anyone can make an ATX form factor. Dell, IBM, all the main Intel all have some proprietary ones that only they can make. So you might buy a Dell PC that you can't ever replace the motherboard on with another ATX motherboard because it's not ATX, it's proprietary, which is why it's best to buy ATX so that you've got more options of things that you can put in it and work with in the future. It's been around since 1995. That doesn't mean it's old. It means that is the basic form factor that we've been working with for a long time. That measurement, 12 inches by 9.6, is very fluid. You'll see that as we look at some of these other slides as we talk about form factor. We talked previously about how the CPU and the memory slots are positioned on an ATX form factor in order to get them to not interfere with the expansion slots. That was one of the changes from AT to ATX. And the power supply uses a very specific P1 and P4 connector for the motherboard and for the motherboard power to the CPU. That's part of the ATX form factor. Also with the ATX form factor, the assumption is the power supply always blows air out of the case to help keep it cool. That's one of the secondary functions of the power supply. While we're talking about that, I wanted to talk about airflow. This is the desired airflow for an ATX system. It should come in through the front and go out through the back. It should come in from the bottom and go out through the top. That's the ideal cooling for an ATX power supply and for an ATX case. It's not always what happens. This power supply in this picture right here is blowing out the back of the case and pulling air in from underneath. If you mounted that upside down, you'd pull it in, out through the case and out, and it would still successfully pull hot air out of the case. And if you had no other cooling, that might be what you do want to do. But in general, it's always going out through the back, coming into the front of a case. Also, this picture up here denotes that the CPU fan should blow back to whatever that cooling is in the back of your case. That's all part of the ideal ATX case and ATX cooling. That's the direction of flow as air goes through a case. You can have fans on the front, you can have fans on the back, you can have fans on the top. When you mount them, you need to make sure that the airflow in the front comes in, the airflow in the back goes out. All the air should be flowing, I should go this way, in one continuous direction through a case so that you have a steady flow of cool to warm to exhaust in your case. That's part of the design of the form factor ATX. When we look at motherboards and motherboard form factors, we've already talked about this previously in Chapter 1, and we're going to go more in depth in Chapter 4. But you see with ATX, those back panel items, then the CPU, then the memory, and that's the flow of the center part. And then you have your expansion cards off to the side that are not interfered with by those items. Also, the ATX power supply is always going to have, this says 24 pin, it's 20 or a 24 pin P1 connector. Also a secondary power supply connector that supplies power to the CPU. It could be 4 pin or it could be 8 pin, depending on the motherboard. And that's one of the things that as we talk about power supplies, we have to look at our motherboard to see what it needs to get the correct power it needs to run correctly. Another picture of an ATX motherboard. Again, we've got our I/O ports, our back panel connectors, our CPU, our memory, and then all the expansion slots to the side. And really this size, the expansion slots here determine what kind of ATX form factor we're talking about. And we'll look at a picture here in just a second of those. There we go. The holes, these base holes, these 4 base holes right here, labeled C, H, J, and F, really are the ones for a micro ATX, and then a flex ATX. Mini, flex. Then we can see micro, and then we can see full-size ATX goes all the way out here. It's how many of those holes it uses on the case. Doesn't mean it won't fit the case, because the back panel I/O port for the smallest ATX to the biggest ATX is always going to line up with these 4 screws and that spot, and then we'll just have more expansion cards as we go off to that side with the different kinds of ATX motherboards. You can see here we've got flex, micro, full-sized ATX boards. The difference is not this. Those holes are going to be there. It's how much further these expansion cards go down, and whether they use these, whether they use these holes when we're connecting it to the motherboard. It's the same thing. The same plugs go into them, the same memory type, the same CPUs. It's just what kind of expansion slots and how big the motherboard gets from there for the different kind of ATX motherboards in that case. And here's another kind of diagram showing the different sizes of motherboards. It starts with the smallest ITXs and then goes out to the micro ATX, full-size ATX, extended ATX. It's just a very specific size and form factor for the different motherboards as you go forward. The last thing I wanted to talk about on form factors is the nomenclature used, or the names used for different kinds of cases. These different ones, from a full-size tower to a desktop to a small form factor to an ultra small form factor, could technically all have the same motherboard. They could all have micro ATX motherboards or flex ATX motherboards in them. It's just how much airflow and how the case sits and what kind of cards go into it. When we look at the tower, we get full-size expansion cards in there, and when we start looking at these desktops and the small form factors and the ultra small form factors, now different kinds of cards have to go in there that are specifically made for small form factor cases. They still have expansion slots, it's just now what can be plugged into them after that. So just wanted to make sure we had a chance to look at the nomenclature in general. When we talk about PCs and making PCs, we're talking about towers. Now, they may be huge towers, they may be smaller, normal size tower like the 790 I've got sitting over there in my classroom. But towers are the PCs that stand up. The name came from a long time ago when towers could be really big. Towers can still sit on your desktop. Small form factor ones can still sit on your desktop. It's just the different sizes and what they're called as we look at different kinds of PCs. Along with those sizes, along with these, when we talk about power supplies and ATX power supplies, we're really going to be talking about tower power supplies, because when we get in the desktop and the small form factor and the ultra small form factor, all of a sudden we start getting away from, this is what I would say is a standard ATX form factor power supply, and then some of those other sized cases all of a sudden need very specific power supplies that are not standard power supplies. So again, in this chapter and forward in this class, when we talk about these things, we're talking about standard ATX, which this one is right here. We're going to look more at those power supplies and how to select them in subsequent videos. So, just to sum up, the computer case and form factors again describe the size, shape, and makeup of that hardware component, and the form factors of the motherboard and the power supply and the case all have to match. They have to screw together, they have to plug in together, and most importantly, the voltage has to be right in order for all those things to work correctly.